Good morning. Today we are starting with lesson 6-1. We will start with our math message like we usually do. A human heart beats about 3.2 million times per month. How could you write 3.2 million in standard notation? Be ready to explain your reasoning. I want you to think of 3.2 million as 3 million plus 0.2 million. I gave each of you a place value chart inside the Canvas module with a list of all the pages that you normally would find in your math journal. So I have that pulled up here on the screen now. So if we fill in a place value chart, 3 million means that there is a 3 in the millions place. 0.2 millions means 2/10 of a million. Since a digit in one place represents 1/10 of what it represents in the place to its left, a digit in the 100,000s place is worth 1/10 of a million. Write a 2 in the 100,000s place to show 2/10 of a million. Put zeros in the remaining places to the right to get 3,200,000. 3.2 times 10 to the 6th power is another way to write 3.2 million. 10 to the 6th power is written in exponential notation. Remember that the raised 6 is the exponent and it indicates the number of times the base 10 is used as a factor. For example, 10 to the 6th equals 10 times 10 times 10 times 10 times 10 times 10. Since the base is 10, 10 to the 6th is also called a power of 10. Imagine that we wanted to multiply a whole number like 3 by a power of 10. What rule have we used in previous lessons to multiply whole numbers by powers of 10? Previously, we would attach the number of zeros indicated by the exponent to the end of the whole number. Why does that rule make sense? Each zero that we attach shows that we have multiplied by 10 one time. Now, would attaching 6 zeros work to multiply 3.2 by 10 to the 6th? Why or why not? The answer is no, it would not work because 3.2 is a decimal, not a whole number. Attaching 6 zeros to 3.2 gives 3.2 million, which is exactly the same number as 3.2. It isn't the same as multiplying 3.2 by 10 to the 6th. In today's lesson, we're going to look for patterns and develop rules like the ones that you already know for whole numbers that also work when decimals are multiplied or divided by powers of 10. Let's suppose we were looking at the problem 3.2 times 10 to the 6th power. If we wrote it out, we would write it as 3.2 times 10 times 10 times 10 times 10 times 10 times 10. If you do all of that multiplication, the answer that you come up with is 3,200,000. Does this result make sense? It does because it matches our answer when we multiply 3.2 times 10 to the 6th. It's the same as multiplying 10 6 times. So our answer should be the same as if we had done it on a calculator. What if we try to divide 3.2 by 10 to the 6th? If you have a calculator that has the exponent function, you can try it on that if you'd like. But when you do it, the answer that you get is 0.0000032. So you can see that dividing by a power of 10 with a decimal gives you a little bit different answer. I also put in the module this page that comes from your math journal. It would be page 196, and this is what the top part of it looks like. The instructions say, use a calculator to complete the table. Look for patterns in how the decimal point moves. Now, it also says there, note, you may need to place a 0 in the tens place to show the location of the decimal point for whole numbers. For example, write 453.0 instead of 453 to show the decimal point. I've done the first one for you as an example. 4.53 times 10 to the first power. The result in standard notation is 45.3. The direction that you move the decimal point is to the right, and you have moved it one place. So go ahead and continue to fill out that box. Once you've finished, advance to the next part of the video. Now that you have finished filling in your chart, it should look like this. 4.53 times 10 to the second power should be 453. The decimal point has moved to the right 2 places. 4.53 times 10 to the third power is 4,530.0. It's moved to the right, and it's moved 3 places. You can continue to look at the rest of the answers to see if you got it right. By now, hopefully, you've noticed a pattern and you are able to answer questions 3A and 3B. So when multiplying by a power of 10, the decimal point moves to the right. The exponent in the power of 10 indicates the number of places the decimal point moves. Zeros are sometimes attached to the right of the starting digits to show how the digits have shifted. Now we will move on to the bottom part and try to do the same thing with division. Now we are going to look at division. If you saw the question on the last page, number 4, it said if you divided a start number by a power of 10, would you expect the quotient to be greater than or less than the start number, and why? Well, it's going to be less than the starting number because you're dividing by a number greater than 1, which gives a quotient that is less than the dividend. So let's look at these examples. It says, use a calculator to complete the table. Look for the patterns in how the decimal point moves. So our starting number here is 67.2, and we're going to divide by 10 to the first. So when we do that, the answer is 6.72. Now, which direction did the decimal point move this time? It moved to the left, not the right like it did when we were multiplying. How many places did the decimal move? It moved 1 place. Go ahead and fill out the rest of the table, and then we will go over our answers. Okay, so I have here the answers that you should have gotten when you were dividing. If you continue down the table, 67.2 divided by 10 to the second power is 0.672. The decimal point moved to the left 2 places. 67.2 divided by 10 to the third power is 0.0672. The decimal point moved to the left, and the number of places is 3. You can look at the rest of the chart to see if the rest of the problems are correct. So as you can see, the rule for dividing by a power of 10, the decimal point moves to the left. The exponent in the power of 10 indicates the number of places the decimal point moves. Zeros are sometimes inserted to the left of the starting digits to show how the digits have shifted. So now we're going to do a little bit of a wrap up of the lesson. First, let's talk about multiplication by powers of 10. So what happens to each digit when the decimal moves to the right? Each digit shifts to the left. How does the value of a digit change when it shifts one place to the left? The digit is now worth 10 times as much. How does shifting a place connect to multiplying by 10? Each time a number is multiplied by 10, the digits shift one place to the left. Why would the number of places that digits shift match the exponent for the power of 10? The exponent tells how many times a number is multiplied by 10. For example, if a number is multiplied by 10 to the fifth, the digits shift 5 places to the left. Now, looking at division, what happens to each digit when the decimal point moves to the left? Each digit shifts to the right. How does the value of a digit change when it shifts one place to the right? The digit is now worth 1/10 as much. How does shifting a place connect to dividing by a power of 10? Shifting one place to the right makes the digit worth 1/10 as much, which is the same as multiplying by 1/10 or dividing by 10. Why would the number of places that digits shift match the exponent for the power of 10? The exponent tells how many times a number is divided by 10. For example, if a number is divided by 10 to the fifth, the digits shift 5 places to the right. Now let's do a few practice problems. Let's look at this example. 2.3 times 10 to the fourth. We now know that we need to move our decimal to the right. Since we're multiplying, our number's going to get bigger. So let me just draw an example of that. There's one place, there's 2, there's 3, and there's 4. Therefore, our answer is 23,000. Let's look at the problem 2.3 divided by 10 to the fourth. We're now going to move in the opposite direction. We're going to move to the left because we're dividing. So there's one place, there's 2, 3, 4. So our decimal is now going to go here. So our answer is going to be 0.00023. We've moved our decimal 4 places to the left because our exponent is 4. Now I'd like for you to complete problems 7 through 13 on that page that we've been working on, and then I will show you the answers. So here are the answers to this page that we just completed. Number 7, 5.8 times 10 to the second is 580. We moved our decimal point 2 places to the right because our exponent was 2. Number 8, 2.8 divided by 10 to the second is 0.028. We moved our decimal point 2 places to the left because it's division and our exponent is 2. 673.9 divided by 10 to the second is 6.739. We moved our decimal 2 places to the left because our exponent is 2 and it's division. Number 10, 23.7 times 10 to the second is 2,370. We moved our decimal point 2 places to the right because it's multiplication and our exponent is 2. 3.1 times 10 to the fourth becomes 31,000. We moved our decimal point 4 places to the right. And 49.2 divided by 10 to the fourth is 0.00492. We moved our decimal 4 places to the left. Okay, you have Math Boxes 6.1 to complete and HomeLink 6.1. They are both located in Canvas. You can download those and then take a screenshot or take a picture of your answers and then upload each of those to where I have the assignment places to turn them in Canvas. If you have any questions at all, please send me a message in Canvas, and I will see you tomorrow.